Hello, my name is Joshua Porter, and for my AP Biology assignment 7.03 System Interactions, we analyzed how systems interact independently on their own and cohesively as a whole to allow humans to do things like speaking right now, as I'm doing. And I've chosen this nice little PowerPoint, nice little background to discuss sickle cell anemia, which is a genetic disorder that shows the system interactions when they're not really working at their height. Okay, what is sickle cell anemia? Let's get an idea of a regular circulatory system. So on the left, you can see the flow of red blood cells, and they take on a nice circular little shape. They're very small, but they flow pretty nicely, no difficulties. But with sickle cells, they take on a curved shape, kind of looks like a sickle. I mean, I'm no genius, but I think that might be where it gets its name from. And these can block the blood flow, and that's pretty much the basis for sickle cell anemia. That's pretty much all it does. But it's homozygous recessive, which means that if both your parents have it, or if both your parents are recessive, you will definitely have it. But if they're just carriers, there's only a 1 in 4 chance that you will get it. So might prefer that one over the latter. So it it's defective in hemoglobin, which means that there's a lower amount of blood cells flowing all at once, and the sickle cell anemia blood cells, they can only last for 20 days, while regular ones, they can last for 100, so they die out a lot quicker, which is not good. And again, they do clot together. What are the symptoms of sickle cell anemia? Well, they're not super obvious, You see someone out in public, you wouldn't really expect them to just have sickle cell anemia. It doesn't really strike the eye. So here we have this nice old man. I found him on the internet, just some stock photo or something. But you can see some things. Jaundice can occur, which is the yellowing of the eyes and skin, which happens when the blood bursts, since it bursts a lot quicker than it would without sickle cell anemia. And you can have painful, like chronic episodes of just pain when your blood cells clot up, and that usually happens in the chest, arms, or legs. And it can sadly result in death because the blood, if it doesn't flow and you're not getting it treated correctly, it can clog up and disrupt the blood flow to your lungs and kidneys and your spleen and your brain, and it can result in pulmonary hypertension, which occurs in about 1/3 of adults, and it pretty much just stops your heart. So not good. And it results in stroke because when the brain doesn't get enough blood that it needs, then, or if it clots up, then it's gonna not have a good time up there. And then priapism, I think I'm saying that right. Yeah, I'm just not gonna get into that one. That one's kind of strange. Okay, so living with it. So first you gotta know if you actually have it. So a blood test will be conducted. So maybe you think both your parents are carriers or one of them has it and the other doesn't. You might want to get tested. So usually that'll happen either in the womb or right when you're born. And so if you do have it, like our man on the right, I guess I've just decided he is our patient with sickle cell anemia. You're gonna want to take a lot of pain meds like hydroxyurea. I think that's how you say it, which will reduce the pain for when you have the very painful clotting episodes. And lots of water, 8 to 10 cups of water usually helps with the episodes. And if it's really bad, a lot of them are sickle celled. You might want to get blood transfusions so you can have just regular or uh, circular oval like blood cells, like normal. And you're gonna want antibiotics in case any of them get infected. It's the clotting can infect many parts of your body, so you're gonna want to cleanse that out of there. So I mentioned what symptoms, or what the symptoms are, but what systems in particular does it attack? So it attacks your endocrine system, which is already a really slow system. That's the one that works like a mail delivery protocol. So you can expect that when its mailmen are blood cells, and there's not as many blood cells to go around, then your delivery time is not going to be too good. And when delivery time isn't that good, and you need to ping your target, the target isn't going to get the stimuli as quickly, so your response is going to be delayed. So that can affect your moods or your just your muscles or tissues, anything that's related to the hormones in your body. And then it can also affect your immune system because the immune system, your T cells and your B cells, which was like your search and destroy cells, T cells search for the virus, B cells activate the antibodies. They rely on the blood, so blood clotting can slow them down, so you're more vulnerable to diseases. Not too good in this time around when coronavirus is killing off people with weak immune systems. And it also affects your respiratory system, which is pretty much entirely reliant on blood to oxidize your blood vessels. And finally, we have the history. This guy didn't invent the disease, thank God, but he did discover it through his patient Walter Clement Newell. He saw that he had the some S-shaped blood vessels, or sickle cell blood cells, rather. And he kind of investigated that, but the term sickle cell anemia didn't actually come around until Vermont Mason coined it in 1922. But 1904, just, uh, the era this man lived in was a critical time for discoveries in biology and genetic disorders and just biology in general.